and then explain how this translates into the underlying argumentation model in the wiki. And after that, I will give a short demo of the wiki, and then I will explain why we have chosen the Semantic MediaWiki as the platform to extend this tool. Okay, let's start with the motivating use cases. So in the first use case, it's about the AgriVoc thesaurus. I don't know whether someone of you knows it. It's a multilingual structured vocabulary with terms from agriculture, fishery, and so on. And it's maintained by the Food and Agriculture Organization of the United Nations in Rome. And it's used worldwide by government agencies. And the objectives in this use case is that we want to support the communication within the FAO team in Rome, and also the communication with the users of AgriVoc, which are worldwide. So here this is a sketch of the processes. So here we have the worldwide users of AgriVoc, and they can submit, for example, suggestions and issues with the AgriVoc thesaurus. And we have here the AgriVoc team at the FAO in Rome. They evaluate and commit changes with regard to these suggestions coming from the worldwide users. And here there's a centrally maintained master copy of the thesaurus. And we have a second use case in this project where this work was done. So it's the Pharma Innova cluster. It's a cluster of companies from the Spanish pharmaceutical industry. And it's about efficient exchange of information between the companies. So here in this case, it was about electronic invoices. And for this purpose, they wanted to design an ontology. And here the ontology about electronic invoices. And all the partners in this Pharma Innova clusters have to agree on this common ontology. Otherwise, they wouldn't exchange the invoices. And the centrally agreed ontology has to be, for example, adapted if the legal requirements change with regard to exchange of invoices, or if a new partner enters this cluster of companies. And here we have a slightly different workflow. So we have here, for example, a previously existing version of the Pharma Innova ontology. And then, for example, here a new partner enters the cluster, or the legal requirements change. And in this case, all participants in this cluster gather together, and then they create the new ontology version, in short. And so what are the requirements coming from these use cases? So on the one hand, we can identify the worldwide distribution of discussion participants. So for example, regular face-to-face meetings are too expensive for these projects, for example. And this is why we need mediated and asynchronous communication between the participants. On the other hand, we have to be adaptable to different models of participation. For example, here in the case of the AgriVoc ontology, we have that all participants can make suggestions and discussions with regard to the ontology which is designed, and only the employees of the FAO organization make the final decision and then implement the solution, for example. While in the case of the Pharma Innova clusters, all participants are equal and they have to discuss and vote for a solution, for example. So we need flexible administration of user rights to be adaptable to both use cases. And for example, this translates to different voting modes for these discussions. And finally, here, this is another requirement that you have these discussions, and on the other hand, the ontology which is changed based on these discussions. And one requirement was to easily find the discussions which are relevant for a certain element, for example, in the ontology. And for this purpose, we want to establish the relation between the discussions and the changed ontology elements, or which are currently discussed. So this was the short introduction into the use case, and now let's come to the efficient support of decision and design processes, like in the case of collaborative ontology development. And here there's a lot of work, but we concentrated here on one of these works, the issue-based information systems, and this is a methodology which supports the solution of complicated problems. So during these complicated problems, you identify requirements for a good solution, and you identify the influence factors on what is a good solution. So the key point about complicated problems is that understanding and solving the problem goes hand in hand. So at the very beginning, it's already difficult to exactly define what is your problem and to understand the problem. So you cannot directly go to the solution step. You first have to understand the problem and all the influence factors. And the issue-based information systems help to structure the discussion and the problem formulation, and then to systematically derive solutions. So originally, the issue-based information systems have been designed for political decision processes, but later it was also adapted, for example, to software engineering. And this is an example how such a discussion in issue-based information systems is structured. So here, the first thing is that you identify the topic. For example, in our case, it's develop vocabulary of terms from agriculture. So it's the AgroVoc project in this example. And then within the topic, you have several issues or problems which you have to solve. For example, here the question, should we define terms in this vocabulary in singular or plural form? And then some suggest solutions, and these solutions are then, for example, supported or objected by arguments. So it's also here the timeline. So first the topic, then the issue, then the solution proposal, and if you have a solution proposal, then it's followed by arguments. Okay, now how does this translate to the underlying argumentation model in the Cicero tool? So we have here the issues, and the issues can have relations to each other. For example, one issue elaborates on a previous issue, or it specializes a previous issue. And these issues are then addressed by solution proposals, which may be alternative to each other, for example, and then you can support or object these solution proposals by arguments. And there are then three special types of arguments: the examples, the evaluation, and the justification. And so you have the explanation below. And why these three argument types? Because in user studies, it has been shown that if you try to stick to these three kinds of arguments, then discussions are much more efficient. Yeah? So then you do not drift off from your original issue, for example, and you come to a solution more quickly if you stick to these three argument types. So this is then the basic idea of the argumentation workflow in Cicero. And then here you have the voting mechanism, and on the other hand here you have what you are editing, for example, the ontology. So you have ontology elements, and the issue refers to one ontology element, for example. And then if you implement solution proposal, then this leads to the change of some ontology element. So here you make the connections between your discussion and what you are currently designing. Here this, for example, is then done in a domain-specific editor like an ontology editing tool, while this is done in the Cicero argumentation wiki, and this is here established by a plugin in the domain-specific editor, for example. So let's come to a demo of the tool. So here, this is the main page of the wiki, so it's a local installation at the moment. And here I've just created the AgriVoc project. Let's click on it. And yeah, so here the main page of such a project just shortly describes the content of the project. So it's more or less the definition of the topic. And here at the bottom you see, for example, the recently created issues and how many contributions are for this issue. And here you also see the users participating in the discussion project. And then let's click here on this issue. And here for an issue, it's also an article page in the Semantic MediaWiki. And at the top you see the issue definition. And then here you see summarized the solution proposals given at the moment. And the discussion is then done on the talk page related to the article. So here you also see again the complete discussion with the issue definition at the top, followed by 3 different solutions at the moment. And here, for example, you see an argument given to support this solution. So here this green cross means it's a supporting argument in contrast to the red minus, which is an objecting argument. And then you can, for example, click here on the reply button and enter some argument. And here you see an explanation of the different argument types. So, yeah. And once the discussion has settled, and you may think about we have a mature solution proposal, let's come to the voting, for example. Then you can start here the voting phase of a project. It can also be automatically triggered, for example, after 1 month of discussion or something like that. But you can also manually trigger it. So let's switch to the voting phase of such an issue. And if the voting phase is running, then you see here the box at the top. And you can click then on vote and select, for example, here one of the solutions which you favor after reading the discussion. Okay, and what did I want also to show? Yeah, maybe here at the bottom you see that many of these informations related to the issue are semantic annotations. For example, when was it created, which decision mode do we have, for example, to be adapted to the different use cases, and which issue state do we have. And this is then also available, of course, as RDF export by Semantic MediaWiki. And now let's switch to the Neon toolkit. So this is an ontology editor. For example, here we may have the AgriVoc ontology. I just have created one concept in it. So here first you establish the link to the discussion project by giving the reference to the URL of the discussion project in the wiki. So you can go here, for example, to the project main page and just copy the URL from the top and paste it here in this box, and that's it. Yeah? So you establish the links by just copying the URLs from the browser into a corresponding box in the editor. And then, for example, if you have here the geographical region concept, which we have discussed, let's see. There you can also establish, for example, a connection to an existing issue, like previously shown, by pasting the URL here. Or you can also create an issue from within the Neon toolkit. I don't know why these exceptions come. So maybe because I fiddled with something, I don't know. So at home it worked. But from within the editor you can also create the issues and just give the title and the content of the description, and let's establish here. So copy the link address, annotate it, Okay. I don't know. So let's give it up. And then you can also go here and click on Show Issues. And then you see which issues are connected to the currently selected element. And then you can browse these issues and discuss it. OK, so that's with regard to the demo. And I think my time is almost up. So let's go back here. So why did we decide on extending Semantic MediaWiki? So we distinguish between the advantages for the user. So the Semantic MediaWiki or MediaWiki has a well-known user interface. For example, many users know it from Wikipedia. And using wiki syntax in discussions can be used, for example, for flexible formatting and interlinking of contributions within the wiki. And so the first one translates to reduce learning efforts for the users. And for us, the advantages during the development of Cicero was that we can take the existing management of users and user rights within the MediaWiki, for example. And we can use the definition of semantic templates and queries for designing the user interface. So many of these boxes and what you have seen in the interface of the wiki are based on semantic templates and semantic queries, for example, the list of the recent issues. And we can export the discussions as REF, and this can then be used for integrating the wiki with the ontology editor, to make the discussions accessible in the domain-specific editor. So for us, it was the reduction in development time and the easy integration with external tools like the ontology editing. Okay, so conclusions. The Cicero argumentation wiki offers more efficient decision processes due to the argumentation model with these predefined argument types, for example. It's based on the established issue-based information systems and advances the use of the more efficient argument types. And it documents all arguments and solutions within the design process, and knowledge doesn't get lost in this way. So we know why we decided to include, for example, a certain ontology element, and we can also easier understand earlier decisions, and we can revisit a discussion if requirements have changed with regard to an ontology. And the last thing is that we can link the discussions with the discussed artifacts like the ontology elements, so that we can offer easier search for relevant discussions and reduce the probability of repeating a discussion with regard to the same ontology element, for example. Okay, here you see the URL for accessing demo installation of the Cicero argumentation wiki. We can also try something in a test project. Okay, so that's it. Thank you, and questions.
Okay, thanks. While the next speaker is setting up, we have time for one or two questions. If there are any. Here.
Is the voting mechanism part of Ibis, or is this something that you
I don't exactly know whether voting is also a part of Ibis, but I think it's a natural extension. So, yeah. So voting is really necessary in these collaborative decision processes. Ibis is more originally designed for face-to-face meetings, where you can easily do votings by raising hands, while here in the wiki context, you need this electronic voting.
Okay. So further questions can be taken offline. Let's thank the speaker again. And,